All right. Hopefully this is all good. So for section 4, I should just go to the notes first. That's the homework. We'll do some of it. For section 4, we're going to start with multiplying, then we're going to do dividing. Although really it's not dividing. You'll see when we get there. For multiplying, this is what we were starting on Friday. When we were looking at conjugates and I have you multiply it out all the way, that's what we're doing here. Because now we're going to do ones that are not conjugates. So that whole, if you figured out the shortcut for the conjugates, it doesn't work here. But we're going to come back. We'll be using the conjugates later on. Here, though, the idea is just use whatever method you're comfortable with doing the distributive property, whether that's FOIL, Bopp's method, Parrot speak, area model, whatever you want to use. Multiply the two binomials together with all the rules that we talked about for multiplying and adding and subtracting radicals. So here, for the very first one, letter A, I'm just going to do the distributive property. 3 times 2, right? 3 times 2, 6. Easy as that. Next one, 3 times the square root of 5. Okay, 3 is not inside a square root. 5 is inside a square root. It combines like this. The 3 is on the outside still. The 5 is on the inside still. 3 root 5. Nice and easy. Then 2 root 5 times 2. So here, the 2's are both on the outside. And let's use some different colors. 2 root 5 times 2. 2 times 2 is 4 root 5. Right? The 2's are both on the outside. They get multiplied together. The 5 stays on the inside of the square root. And then the last one, 2 root 5 times root 5. The 5's are both on the inside of the square root. They get multiplied together. So just essentially 4 little simple multiplication problems like what we did last week. Does anyone have any questions about how we did that? Okay, so now let's clean it up. What's the square root of 25? 5. Now, you could have written this as 5 times 5, pair of 5s comes out. Is everybody clear? And it's written up on the board here. The square root of 25 is 5, not the square root of 5. I still have people that when they see that square root of 5 times 5, they say, okay, well, that's 5, but it's in a square root. No, you took the square root already. The square root's gone. Does that make sense? So don't do that. Square root of 5 times 5 is just 5. No square root left. So that means this right here, 2 times 5, this becomes just 10. Right? 2 times 5. No square root left over. And again, if you ever want to check that, if you're not sure, does that make a perfect square root or not, just grab a calculator. Square root of 25. I still have the 6 over here. And then right here, okay, second period wasn't quite awake this morning. How about you guys? What's 3 root 5 plus 4 root 5? So that is still not the chorus response that I'm hoping for. But are we okay? 3 and 4 make 7 root 5. So plus, and again, I understand it was a long week. Well, it was a regular weekend. We get a long weekend coming up, right? We get a 3-day weekend. But for now, again, we're just refreshing ourselves from that last 2 days off. So those two, 3 and 4 make 7. 6 and 10. I can add those together. I'm just going to combine like terms. 6 plus 10 is 16 plus 7 root 5. That is my answer. So essentially, we just have a couple little problems, some little multiplications, some little additions, put it all together, get an answer, often with a real part and a root. Well, actually, they're both real. A whole number part and a square root part. There's a lot of that. Like today's lesson is a lot of little steps, not big crazy steps for the most part. We'll get to one problem that's rough, but most of them, like if you can handle this, you can handle 80% of what we're doing today. Letter B, same idea. Do the distributive property. 4 times 5 is 20. 4 times -6 root 2, right? The 4 and the 6 get multiplied together. 4 times 6 is -24. And then we still have the square root of 2 in there. 4 and the 6 are outside. They get multiplied together. 2 stays on the inside. Then 3 root 2 times 5. -3 times 5 is -15 root 2. And then last but not least, 3 root 2 times -6 root 2. -3 times -6 is +18. And then root 2 times root 2, you could do root 4, root 2 times 2. Distributed property, 4 little multiplications. Now, the orange one here, 2 times 2, I've got a pair of 2's, that comes out. 18 times 2 is 36. So we clean that one up. This will often happen where you get one where there's the square root, but it simplifies. Then we often have kind of 2 in the middle that combine. Here they're both negatives. -24 minus 15 is -39 root 2. And again, it's negative. And I still have the 20 over here. So right now, I'm looking at, let's put the plus sign in front of the 36. It was positive. And then we still have that 20 from out in the front. So this is what I'm looking at right now. So I can combine the 20 and the 36. Even though they're not next to each other, it's just a bunch of additions and subtractions. Combine the like terms. The signs go with the thing that comes right after them. So it's a -39 root 2, but a positive 36. 20 plus 36 makes 56 minus 39 root 2. There is my answer. We're still doing okay. Yes. So the 56 was the 20 plus the 36, the two whole numbers combined. Are you good with where the 20 and the 36 came from? Okay, so yeah, just add them together. Let's do one more and then let's do some of the homework. Okay, this one's squared. The temptation is to say, oh, square roots and squares cancel out. They do, but we've got an addition in the middle of this. And so technically what you're going to do here, cross out that squared and just write it again, root 7 plus root 5. Okay. And then do exactly what we're doing on the last few. Root 7, root 7. This one's kind of nice because it's all square roots. So everything's just multiplied together inside. So I get square root of 7 times 7. Then root 7 times root 5. 7 times 5. Then another root 5 times 7. And last but not least, root 5 times root 5. Are we okay there? So now we're just going to simplify. The 7s, square root of 7 times 7, that's a pair of 7s. Those come out. Square root of 7 times 5 does not simplify. There's no pairs there, so it's just the square root of 35. Same thing with the purple, 5 times 7. That's another. 5 times 7 is 35. And then the last piece here, square root of 25 or 5 times 5. That's a pair of 5s that comes out. Combine your like terms. We've got a 7 and a 5, which makes 12. And then how many square roots of 35 do I have? 2. 30 square root of 35 plus another square root of 35. makes 2 square roots of 35. Let's use a color that matches there. 35, 35, 2 square roots of 35. There's my answer. Now, some common mistakes. Can I add the 12 and the 2? No. One's a square root of 35, the other's not. Don't put those together. The 35 doesn't simplify because it's just 5 and 7, no pairs. We're good. All right, I want you guys to try number 3, I think 3 and 4 on the homework. Let's take a look. Yeah, those will be a good sampling. Do 3 and 4 on the homework right now. Neither of those is exactly like a problem that we just did, but it's got all the elements of what we just practiced. So try it yourself. If you're stuck, check with someone in your group. If you're all stuck, raise your hand, get some help. It would be 1 square root of 25. And the square root of 25 is just 5. Those would be 5. Yeah, that looks perfect. You've got 4, you've got 5 on the side. Here you've got 2, 5, 7, 8, 5. So there's a bar. There's -4, 5. My outside number stays with 1. But you're not multiplying by counting. It's still a negative 2. What is number 4? It's happened to stuff. Yeah. But you have any questions right now? Okay, so why don't you try this? You multiply the outside number, multiply the inside number. Like you're doing 4 little multiplications. And then after that, you start adding. So it's my Does this So Because it's not simplified. So it's very important what you do. And then multiply that by the 20 out. That's the thing. You'll often go with that. It's not like this. The 140. 140. Oh, he's landing out. Yeah, that's right. After that, 8 or 7. It's just, yeah. All right, let's try those. See how we did. All right, so first things first, is everybody good with number 3? Rewriting this as 2 minus the square root of 5 times another 2 minus the square root of 5. And that's going to be the most straightforward way to make sure you don't make any mistakes on this. So what am I multiplying then here? What's the first thing I should multiply together? Kaiva. What does that make? Yeah. So just do the 2 times 2, that makes 4. Let's keep going. Alyssa, what do we multiply next? Yes. Yeah, let's do this. Let's just stay in the same order I've been doing. Again, if you do it a different order, that's okay, as long as you don't miss any. And so what does that give us, Alyssa? -2 root 5 is perfect. Let's get another one. If we can get someone that's here today, that'd be good. Nick, what would I multiply next? Okay, what does that give me? Perfect. And we got one more. Emily B. All right, so is everybody good there? Negative square root of 5, negative square root of 5. What does that make? Right, is everybody clear here? You could write plus the square root of 25 if you wanted to, or you could go straight to just square root of 5, square root of 5 makes 5. That's a pair of 5s. Is everybody okay there? Does everybody understand that for that first step, everything is getting multiplied together? You're just deciding, do I multiply, are these numbers both on the outside, or do I have one on the outside, one on the inside, so they stay where they were? What do I combine? But it's all multiplication. Now, once you've simplified it, you've done all the multiplication, now is when we start adding or subtracting. So what can I add or subtract? Alejandro, what's something I can put together here?
4 and the 5.
All right, and what does that make?
9.
Yep, 4 plus 5 is 9. And we've got one more thing that we can combine here. Class. Rasan Preet. What's the one other thing I can put together here? And what does that make? Yeah, sorry, I was just a little quiet there. That's perfect. -4 root 5. Does that make sense to everybody? -4 root 5. Everybody okay? So let's do one more. Go over number 4. This one is a little bit harder because you got numbers on the inside and outside, but it's not bad. Here today. Julian, what's the first thing we're multiplying together here?
The 2 and
All right, 2 and 5, what does that make? Perfect. 2 and 5 makes 10. Going on. Next thing that I should multiply. Joey, what should I multiply next? 2 and the 4 root 7, what does that make? Perfect, 8 root 7. Right, the 2 and the 4 are both on the outside. They get multiplied together. Square root of 7 stays as it is. And from there, what should I multiply next? Caitlin, what should I multiply next?
I mean, 5 root 7 and 5.
There you go, 5 root 7 and 5, and what does that make? 25 root 7. And let's get one more. LJ, what's the last thing that gets multiplied together here? And what am I multiplying? Yeah, what does that make then? This is one of the harder ones. What gets multiplied together? Like, how do I actually get an answer? Okay, and what does that give us? Good. 4 and 5 is 20, right? Yeah. So you get 7 times 7. You can write as 49, or you can go straight to, I have a pair of 7s, that comes out. So really, this ends up being 20 times 7. End up with kind of a big answer here. Is everybody good with this being 140 for that one? So at this point, though, what can I, oops, bring that back. What can I actually combine? Ethan Rocco, what can I actually combine? All right, so 10 and 140, what does that make? All right, is everybody good there? 140 plus 10 makes 150. And then we've got one more piece to put together here. Ashram, what can I put together? What does that make? 33 root 7. So that last part, that's where we're doing the adding. There is my answer. So again, just a bunch of little multiplications, then several addings and subtractings, and we've got our answer. Does anyone have any questions of what we've done so far? Now, if you hit a conjugate and you know the shortcut, you can use that on the homework. But a lot of them for the multiplication are not conjugates. So you're having to actually multiply it all the way up. You have everything you need at this point to do the front page of the homework. We're going to keep going, though, and look at the second piece, which is division. We're actually going to skip examples D, E, and F. They're great examples, but they're exactly what we were just doing. Does that make sense to everybody? So we're good. We don't need to go over those. Let's jump down here. So here's the problem. They want us to do division. There is no way of doing division on this. So we're actually not going to divide. What we're going to do instead is rationalize. We're just going to make it so that there's no square roots on the bottom. And the way we do that is with those conjugates. We said on Friday that conjugates, when I multiply them together, they simplify completely. No more square roots. I get just a whole number on the bottom. So that's what we're going to do here. Now, the trick is you have to know what the conjugate is. Literally on the test, if I see you write out the conjugate, that's a point on that question, because that is the core idea for what we're doing right now. So for this one, I see that 3 minus root 2 at the bottom. There is no way for me to divide that. What I'm going to do instead is multiply top and bottom by 3 plus the square root of 2. Again, I can do it to the bottom as long as I do it to the top, so that really all I'm multiplying by is 1. Literally take the denominator, take the bottom of the fraction, switch the middle sign. That's what you're multiplying by. So now on the top, just distribute. 5 times 3 is 15. 5 times root 2, 5 root 2. Top's done. The bottom now, you can multiply it all the way out. 3 times 3 is 9. 3 times root 2 is 3 root 2. Negative root, oops, I didn't actually draw that line there. Negative root 2 times 3. negative 3 root 2, and negative root 2 times positive root 2, negative root 2 times 2. Now you should see some things that simplify here. 3 root 2 minus 3 root 2, it's gone. Root 2 times 2, that's a pair of 2's, just minus 2. So really, the entire bottom becomes just 9 minus 2. That's the goal here. What's 9 minus 2? 7. So my final answer here, 7 on the bottom. (15 plus 5 root 2 on the top. Now, that wasn't too bad, but why do that much work when you can do half that much work? You can do this with the shortcut. Once you figure out how those conjugates work, you can save yourself half of the time we just did. Okay, so let's do that. From now on, if you understand what a conjugate is, you can save yourself a ton of time. So everybody look at this. See the bottom there? The conjugate is the opposite sign. Everything else is the same. So I'm multiplying by 7 minus the square root of 6. I'm going to start quizzing you on that. You should all be able to recognize what the conjugate is for those. Literally the exact same thing on the bottom, but with the opposite sign in the middle. Top, exactly like what we did before. Root 5 times 7, 7 root 5. Root 5 times the square root of 6, negative root 5 times 6. So that's all the same. The bottom, though, instead of multiplying everything out, it's a difference of squares. It's the first thing squared minus the second thing squared. You know the middle terms cancel out. So this is going to be 7 times 7, 7 squared, minus the second thing squared. So 7 squared is 49. The square root of 6 squared, right? Square roots and squares are inverses. They cancel. This is just minus 6. This all becomes 49 minus 6 is 43. On the top, I have 7 root 5 minus root 30. There is my answer. The one step that I need to see from you is that conjugate. I need to see that you're multiplying top and bottom by that. If you want to go straight from there to that 43 on the bottom, you can probably do that, some of you. You figure out, okay, it's just first thing squared minus second thing squared. You can do that in your head. But I'd really like to see, I need to see some work. And the work that I really am going to be checking is, do you have that conjugate top and bottom? All right. Let's go ahead then. I want you all at your table groups real fast. Tell me what the conjugate is for letter C. I'm going to quiz one of you on it, so make sure you know. All right. Davian, what's the, oops, that's the wrong one. Davian, what's the conjugate? Okay, real close. What's the sign in the middle? Does that make sense? It's the opposite. So you're multiplying 2 root 7 plus 3, top and bottom. Now, this one is by far like the hardest one. You just get these giant numbers, okay? I actually am not going to do this one with you guys, okay? Because it takes so much time and you don't learn anything new. because you all know how to multiply big numbers together. It just takes time. Does that make sense to everybody? Does everybody understand though, the bottom of this, here's the one thing that I will show you. The bottom is going to end up being 2 root 27 squared. So that means when I do that, 2 root 27 squared minus 3 squared, right? It's always minus. This is going to become 4 times 27 minus 9 on the bottom. Does everybody see that the 2 gets squared and the square root of 27 gets squared, but the square root and the squared cancel out for that 27. Just 4 times 27. 4 times 27, I think, is 108. Yeah, 108 minus 9. 108 minus 9 is 99. So if you wanted to work that one all the way out, you would end up on the top. So again, I'm not going to do the whole thing. I'm just going to tell you, we're going to skip a lot of steps. If you don't know where these numbers come from, don't worry about it. The idea is if you multiplied it all the way out, you would get essentially 78 root 3 plus 336 divided by 99. The only reason I even have this on the notes is so that I can show you what happens when all of the terms have something in common. All 3 of these numbers are divisible by 3. So I can reduce this. 78 divided by 3 is 26. So I have 26 root 3. 36 divided by 3 is, sorry, that was not 36. That's 336. 336. 336 divided by 3 is 112. And 99 divided by 3 is 33. That is by far the worst one that you're going to see because it's just got huge numbers. So I don't want to spend a whole bunch of time doing it. Instead, I want you to take the next 15 minutes here to work on the homework. Specifically, I want you guys to try on the back page. Let's try number 18. Give you guys 3 minutes to do 18. Let's check that one real fast to make sure we've got the idea down. And then I'll let you guys keep working. So again, you're doing all the evens for the homework tonight. If you get completely stuck on the last one, do your best. Hopefully you remember from geometry, those of you that were solid on geometry, hopefully you remember the difference between area and circumference. Try your best on that one. But again, everybody, 3 minutes, not even 3 minutes, 2 minutes to do 18. The square can't be just going to be the square root of 7. Right, because you square root of 7 times square root. The only reason you have 21 up here is 3 times 7. But that's 3 times. So let me see if you don't like that. I don't get to actually do that. All right, let's go over that one. First things first, decide on your conjugate. What am I actually multiplying top and bottom by? Emily, why? What am I multiplying top and bottom by here? 8 minus the square root of 7. So then what does the top become? Emily Balch, what does the top become? Uh-huh. And go ahead and keep going. Ooh, okay, what goes inside that square root? 21 is correct. Does that make sense to everybody? 3 times 7, get that 21 in there. Now the bottom. I need someone to give, I'm going to call on somebody. I want you to give me the shortcut answer, but without the final step. Don't actually subtract them, okay? Not here today. So, he's not in this class anymore. Jesseline, what do we end up with on the bottom before you do the subtraction? Yeah, so 64 minus the square root of 7 times 7, or just 7. Does that make sense to everybody? That's the shortcut. 8 squared minus root 7 squared. Do that subtraction. So Joey, what's our final answer here? Yep. 57. Yep. That's our final answer. So again, evens for the homework. You've got about 6-7 minutes here. Get a couple more done. Ask if you have questions. That's it for today's lesson.